recording. Okay, we are very pleased to have Joel Hokuto Ide, who is an ex-atheist converted to evangelical faith, a data journalist focusing on mission. Joel is the editor-in-chief of Christian Today Japan. He graduated from International Christian University with a BA in computer science, earned an MA in information technology, and now is enrolled in the PhD program for Global Theological Study at Olivet University, or Olivet University. So go ahead and share a screen, Joel, and go right ahead. I think you already got the screen shared, and begin your lecture. Thank you so much.
Okay, thank you. So you all see the first screen?
Yes.
Okay, good. Let me start now, the timer. 1 hour. So the Missioinformatics is the new word which I coined recently. And then I was trying to promote that for name of the academic field I'm trying to focus on. So let me explain about that and how information technology contributes to mission study. So let me introduce, actually I was already introduced, but there's slightly detailed version of my introduction. And you might want to read later because I'm going to share the presentation file later. So let me skip this for now. And let me recap the history of world mission statistics. And then this is biased onto more United States and more evangelical circles. So please note that. So being said that, 1974 Lausanne Conference, I think this is one of the most important moments for the missiology. This is my personal opinion, because unreached people group concept was developed by Ralph D. Winter. And this was moving moment to rethink how Christian mission in the world should proceed from that moment. And from the time, many things happens. Global Mapping International was started from the campus of Dr. Winter. And Joshua Project, some of you may know already, but statistics is gathered in the website, and then anybody can download the data from that website. And relatively unknown thing is about Olivet Institute of Technology. This is a small San Francisco school, but only focusing on raising the professionals who thinks the world mission is most important. The professionals are mostly tech engineers, technology specialists. And I was also graduated from this school. And 2011 to present, a form of a community is started. It's called Global Community of Mission Information Workers. And this is the gathering of people who work on the information of, for example, status of the mission field, and then other statistics information is gathered by those people. And I recently started to communicate with the people in the group, and I want to emphasize the importance of this. And from 2018 to present, Global Data Initiative. This is a survey done by OC International, and it is gathering the information needed for better decision making for mission strategy makers. Okay. So we started to talk about mission information workers. Those people are not on the front side of the mission, but they are working in the back side. Like, there is front line and the back line in the war zone. These people works on the back, behind the screen. And then what they do is they gather information so that the decision makers can do better decision based on accurate, detailed, and specific data. And I'm one of them. Okay. So as an information worker, mission information worker, I created a project called Church and Station. And this is a national map which visualizing the unreached areas of Japan. Unreached people includes Japanese. And this map was launched by Christian Today Japan May this year. And already 200 days passed as of now. And after launch, the map served more than 13,000 page view for more than 1,400 users from 20 countries and more than 260 cities. And average user spent 30 minutes. Some of them spent 7 hours to use this map as a tool. And if we accumulate all the time which was spent by users of this map, it becomes 200 hours. So what this map does is suggest where to plant new church in Japan. When you look at the map, you will see the orange and the blue. Orange one is a church and station close by each other. In this map, the blue dot is next to the 3,000 meter button on the left of the map. This means you can specifically search the combination of the church and the station, which is within 3,000 meter, which is 3 kilometers. And those are the highlighted as orange. Orange dots are the churches, and the blue high bars are the stations. So with this, you see some of the churches are connected with some of the stations. And then some of the stations are not connected to any churches. Thus, you see the stations, train stations, which is not reached by any church. So church planters can try to think that, oh, maybe there is no church around here, so let's plant a new church here. Let's see the example of the Yakuza station. Yakuza station is shown in this very front, YAKUSA. So if you see the map around the Yakuza station, you see Aichi Institute of Technology nearby. And then there's some rice fields, mountains, post offices. And then you can start constructing your mission strategy immediately without thinking if there is already churches or not. So this is the benefit of this map for the church planters. Right. So based on this project and the lessons which I learned from this project, I want to proceed this lecture, and there's two things I want to focus. So this project as a form of data journalism. Why? Data journalism have 4 steps, and then each step is possibly applied to the mission study in a way that trying to do the similar things in a study, academic study. But this is a journalism project, but getting data, analyzing data, understanding data, and then trying to visualize data. This process is, I think, similarly performed by academic works. So that's why I would like to share this project in a view of data journalism. And the second one will be the third framework for mission. This is more like a conceptual thinking for how world mission can be proceeded, how world mission can be improved. So let's start from the first half. So Church and Station as a form of data journalism, there's a very good handbook for data journalism. It's called Data Journalism Handbook. It's free and it's linked to this slide. So after this lecture, you might want to click this link and then download it, and then you can take a look. And I want to follow the steps which is described in this handbook. The first one, forming data team. Second, defining data. Third, understanding data. Fourth, delivering data. First step to start data journalism is forming a team of leader, journalist, and engineer. Each of them need to understand the value, mission, and the passion to do this project. What kind of projects should we start? What kind of problem we want to solve by this data journalism project? So this is the team. For me, I was both journalist and engineer. So I just have to consult with my leader, the boss, to if I can do this project or not, or if he agrees to do that or not. Thankfully, he invested in me the time to work on this, and then he kept waiting for me. So this is how this project started. And I started to gather station data. And why station? People might wonder. Japan has actually one of the most developed public transportation covers almost all the cities. So you can go virtually anywhere by train. If the place is not countryside, if you go to countryside, you have to surely take the car. But in terms of mission, there's a lot of people living in a city, and then they never heard of gospel. So that's why I prioritized the cities. And the most populated area is already covered by the train. So that's why I chose station. The church. In Japan, there's around 9,500 churches. And I started to gather the information of each church one by one, like last year. And then it took 1 year to gather everything. The reason why I started to gather is because I was in United States for 10 years, and then I was absent from Japan. And then I didn't know what's going on about mission of Japan. That's why I had to update my knowledge. So to do that, I started to go through internet, go online map, travel around Japan, and then try to look at as many church websites as possible so that I can know current status and then what kind of problem they're having, what kind of goals and the ministry is happening in Japan. Okay. The thing I had to consider was between church and station, there should be certain amount of distance. But how long is acceptable to commute from a house to a church through station? Most of the decision point for going church or not going church could be decided by the length from the station to the church. If you have to walk really long distance from the station to the church, some people don't want to go. Some people might be too young or too old or too sick, or some person is disabled. For those people, walking long distance will be difficult. And the other thing I had to consider was, even though those people might not have enough income to purchase car, in that case, public transportation is the only way to go to the church. So I wanted to focus on the public transportation users above car owners. And when I started to work on this project, which technology should I choose? That was the first question. And then I think it is the most important question for anybody who is trying to work on the data journalism project. There's many reasons why we have to really consider seriously about what technology we want to use, we need to use, and we should avoid. There's many things we need to avoid. There's many pitfalls, and then many problems, unexpected, could happen. And then because of those problems, a project may fail. And I saw many IT projects failed because of the not enough considerations and the wrong choice of the technology. So if you want to try any related project, I really highly recommend that you will choose technology really seriously. So for those who are not tech background, I want to give you some analogy of how IT project is formed by different roles. So some of them is human, some of them is not human. That means computers, machines, or some virtual things, the files. Programmers are like, if we compare to the cooking, they are the recipe writers because they instruct computer to do something. Like, recipe writer can instruct cook by writing recipe. And then programming code is like recipes, it's in the programming code, there's many things written to instruct computer what to do. You will communicate with computer by writing code, programming code, like you communicate, like recipe writer communicate with cook. And programming library, this is like more existing recipes. So programming code is the future recipe you are going to write from scratch, from nothing, from zero. But programming library is already written by somebody else. So you can just copy or modify to use it. And programming language is like a tools, smaller tools for the detailed work to chop, cut, smash the ingredients. The ingredients in this analogy is like data. Why? Because you would take that as a form which is not able to consume easily. And then you do something with the data. And then after that, the data is transformed into something you can consume. Like ingredients are turned into meal, which you can consume by eating. And the other things, database. This is really important for the people who works on data. Why? Because database do some heavy lifting job for us. The really difficult job, which programming language is not able to do. For example, store a lot of amount of data in database, and then change everything of them by one. At once, they can be changed into some other type of data, or they can be organized, they can be sorted, they can be connected with other data. You can ask database whatever you want to perform the large or small type of data change or manipulation. So I try to use the analogy of the refrigerator or oven or storage to put many ingredients and then do something on the ingredients at once by pushing a switch, like you push the oven switch. You usually don't know what's happening in the oven. I mean, what is the mechanics of the oven? But you trust that oven will cook well. Likewise, database is similar. You actually don't know what's going on inside of that database, but you trust database to perform certain manipulation of the data. You can check, you can verify if the calculation was correct or not, but you usually can trust. Okay. Being said that, I use the data database, which is called Neo4j. Neo4j is a kind of graph database, and then this is called graph database because of the graph theory in mathematics. And this is not the graphs like bar chart or pie chart. You can click the link later if you want to go deeper into the mathematics. But let me go more for that. Why I chose it? Because in the world of data journalism, a graph database Neo4j was really popular, and then it was used widely. Most prominent case was Panama Papers. Maybe some of you may have heard about it, but it's a scandalous reporting of very high-class people doing dirty things in the money. And then through analyzing data, many facts were unveiled. So this made the database really famous, and I really wanted to use it. And there's other things which I had in the previous databases, which means it's called relational database. And most important and the widely spread database is called MySQL. And this is most popular. And then most of the people are using it, but I didn't choose because the structure of the data is not fitting, I felt, to this project. So For example, how to use the database. I need to talk to database. How? With a language called Cipher for Neo4j. And then this language can be read by humans and also computers, both. So both can read these letters. It says a match. A match means, get some data which is matching to the following conditions. What kind of conditions? Station is connected to a church. And then how is it connected? Where distance is smaller than 1,000. 1,000 in this case means 1,000 meters, so 1 kilometers. And then return station's name and then distance and the name of the church. So that's the meaning of these sentences, 3-line sentences, which is sent to graph database Neo4j. The result will be shown like the image in the following. So there's a blue circle, which is representing the station, and 3 orange circles are representing churches, which is nearby 1,000 meters, within 1,000 meters of the station, which can be seen in the map on the right-hand side. Okay, so the other 2 programming language, I chose Kotlin language. What is this language? It's a general purpose. So basically, related to IT, most of the thing can be done. Any kind of work can be done according to this language. And I can ask computer with whatever task using this language. And then I'm really used to use this. So I chose this. But I want to mention that if you want to manipulate data, analyze data, and then do any work, any kind of work with the data, and you are not proficient in any type of programming language, I recommend Python language because it's most popular language. Why I didn't choose Python? Because I learned Kotlin and the Kotlin's brother language in my school, and then I used it in my work. So most of my career is based on this language, so that's why I used it. This way, I am explaining why I chose certain technology, because the reason is really important. If you don't have valid reason to choose certain technology, you miss something really important, which may cause the failure of the project. That's why thinking a lot about the reason why I choose certain technology is really important. Okay, so this is the example of how we can write computer to do some work in Kotlin language. In this example, distance of 2 locations is calculated using 2 coordinates of 2 places. There's a lot of math, and then radius of the Earth is also included here. This type of calculation is really done fast in the computer. For human, it's really difficult and taking long time, can make mistake. But when I did this calculation, like for a lot of pairs of church and stations to calculate the distance each other, like there was around 100 millions of pair. And then the calculation of distance finished in 2 minutes. 100 million calculation of this in 2 minutes. That's how computer is speedy, calculate many complex math problems. Okay, so this is different example that I calculated. This was most important of this project because through this calculation, I was able to get the unreached stations. And then on the bottom line, stations record that remove all. So remove all what? Remove all the station which have reach from the churches is removed. That means leftover is stations without churches. And this was done in the Kotlin language, and then features which is already built in, which is already created by some other people. And then I was able to use their contribution to the technology to this project. So this was not done by myself, but there's many other engineers who already worked to solve similar issues. And then I'm getting the fruits of them to reapply to another issue, which is related to mission. That's how information technology is applied from secular world into mission study. The fourth step is how to show the data. So after calculation, I was actually wondering, what should I do? Why? Because what I got was this table. So the 3 columns and the 7 rows of table was all I got after calculating all the data. So if the walking distance gets longer, the reach from the church increases. Reach from the station to church increases. But this is not that much helpful information for the church planters. It's just table of numbers. So how can I show this in a way which helps church planters? That was the next question to ask when I was trying to visualize this data. So I picked up a paper and then tried to draw something, and then the thing I drew was the circle, which means reach or working distance. And then church and station connected each other if it's in the walking distance specified in the left column. So the first column is 0 meter to 500 meter. If the church is inside the range, it's connected in the orange line. And second row, if you look at that, the number of orange lines increased into 2. Why? Because the walking distance definition is increased. So there's 2 stations connected to 1 church. The third row increased 1 more connections. This way, I started to build the concept of how to visualize the data. And then the next step was to, getting some technology to make it happen in the real world. So the idea was in my head, in my mind, but it was not materialized into, visible website or visible computer screen. So what I need to do was try to find visualization technology which I can reuse, because I don't want to invent from scratch. it's really difficult to invent such things. But thankfully, I know that there must be many people already using this type of technology, because I watch many tech newses and trying to follow tech trends. That's why I'm sure that there must be already somebody made some technology. And I remember that in 2011, I saw a globe with a bar chart representing, the height is representing the population of the city or the area. And then it's showing in this screen right now, and it's made by Google. And I thought, this could be able to reuse for my project, Church and Station. And I tried, but failed. Because it was maybe experiment for Google, and then it was not serious product for the users to be modified or reused. So reusability is really important for technology. The next second candidate, which I chose as a application, was called Mapbox Studio. And this was really good product. And then this is made for reuse, made for those who want to create custom map. So that seemed me, it's really good product to use in this visualization project. But there was also a problem. It was not flexible enough to switch the walking distance from 500 meters to 1,000 meters, something like that. So I made a lot of progress by making customized map, but still I failed by choosing wrong technology. So if you choose wrong one, what you lose is time, actually, time and effort. But there is something you can gain. What is it? The lessons and the some skills and the knowledges. So because knowing all technology ahead before using is impossible, we have to do some try and error when we use some when we do some new project, when we do some new tech project. Then go forward to use better technology which is fitting to that project. And then finally, I came to encounter the fitting one. So it's called Mapbox GLJS. And then this was used in the real project. Currently, this one is working now. And this was all good. So all the criteria, conditions are met. So it was still bothersome to use this compared to Mapbox Studio, but it was bearable. I was able to overcome the bothersome usage. And instead, I got flexibility instead of botherness. There was a detailed manual, so I could read that. And then I understood how to use this product. And then it was easy to use. It's also free. So everything went well. It went well. But there's another thing happening. So there was something not shown well. There was a bar chart. Bar chart shaped really strange way. I didn't know why. And I came to know that because I was calculating the bar chart, the base and the surface wrongly using just a numerical calculation. just adding 1 for height, 1 for width, then I thought that would make the square, but I was wrong because I didn't know the geographic theory well. So I tried to find out what was the problem, and then I came to know that I have to calculate in a way that Earth is circle, and this was the solution. So to make a square on Earth, what we have to calculate was more complex things. The square on two-dimensional surface is just a square, right? The width and height is same. That's a square. But if you try to draw square on Earth, what's necessary is you need to calculate longitude and latitude in a way that it will form the same distance by the radians. And then the result in the many trial and error, I got the perfect square, and my bar chart looked fine. This was not the end. So there's another thing I had to work with. That was user interface. This is like buttons, and somewhere users will touch and then control the map in the way they want to navigate or change the settings and then change the language. And this was also many considerations to me, because I don't want to make the user see less amount of the information because of the controlling widgets. That's why I try to make the simplest and narrowest controlling panel. And there had to be technology to use. Okay, so that's how I created church and station project. And then some of you might wonder if big data was used in this project. Yes and no, actually. Yes, why? Because the background map was big data. And the big data is really big in a way that one computer cannot process it. So if you bring the big data into your computer now, your computer will be just fed up and then cannot handle the amount of the data. What you have to do is extract some meaningful amount of data and then organize it and then present that small data into one computer. This process is needed to use big data. And then 3 types of big data I can think of is used in this project. First one is background map. Second one is the church data. Actually, it's from Google and Yahoo. It's from also internet, the many websites. And then internet itself is big data. And then Google is gathering a lot of data from internet and they're forming big data into their company. Third data is government. So big company or government usually is using big data. And then some of it is available for those who want to use. And sometimes it's free, sometimes it's paid. But if you search around, you will find it. And then especially from government, it's called open data. And I want to share the tech trends on big data. Big data was really popular, and then many people tried to make use of it in maybe from 2011 until now. But big data related technology got advanced. That's why it's not searched around, and then it's not appearing in search trends in a high amount. Instead, recently, machine learning and data science getting really popular instead of big data. Why? Big data didn't become less popular. Instead, machine learning and data science to utilize big data developed. That's why those two other areas of technology is really highly popular right now. So you might want to check how to use such technologies for mission study. Okay, so let me move on to the next half of the lecture, and let me quickly pass this. Conceptually, I think this project is a third generation framework. So let me explain what is the first and second. So when Jesus told, go and make disciples of all nations, yes. This was the first framework to start with the world mission. How to think about how to progress world mission, nation by nation, all the nations. Then we came to, the mission strategist came into a problem. What kind of problem? Only certain group of people were reached and then evangelized in a nation. Even though many nations are already evangelized, actually most of the countries are already, visited by missionaries. But what is missing now? That's why Dr. Ralph Winter started to come up with the unreached people group concept. So this is the second framework, I think. So even among one nation, which already welcomed the missionaries, and then some Christians, indigenous Christians are already doing some mission, there are some group of people, ethnic group or any type of group, they are not reached by any Christians. There are not any Christian movements occurring. Nobody is heard about gospel. Those people are called unreached people groups. And then after 1974, reaching to these unreached people groups, especially from the evangelical circle, become the main focus of the mission. And what happened? How is it going now? Unfortunately, not all the people groups are reached, especially, my country, Japan. There's less than 1% population Christianity. What's happening? And then what will be the help? How can we improve this situation? So this is the place third framework can be come into. And then this is my just personal suggestion, but per unreached area among a people group could be the third framework. Why? Because Japan is so big, it's so big that considering Japanese people as one people group is, too ambiguous. Let me define unreached area. Unreached area is especially defined in a unreached people group, and then distinguish the areas. Some area there's churches, somewhere there's no churches. So among unreached people group, there are some areas already reached. There are some other areas not reached. Let's distinguish with a geographical precision. Precisely if we came to know where is already churches, where is not churches, then our strategy become more efficient. That's the idea. And this is possible because of technology, because of the advancement of technology and democratization of technology. What is democratization? So when a new technology come into the place, usually that technology is available for only certain people, small amount of people who have a lot of money or a lot of computers. Then historically, what happened in the technology world is those technology became cheaper and cheaper as time goes by. And in the end, usually it becomes free. So I'm using mostly free technologies to build all of the project, which is impossible before. So this is the democratization of technology. You can use new technology for free. And then the other advancement helped me to proceed this project. And the other thing is raising Christians who is skilled with technology skills. And what? I was able to do this project because I was hired to work on this. So these three aspects we can think of when we successfully, conceptualize, materialize the unreached area concept into the actual project. Being said that, when we look at the mission of Japan and relationship to the unreached area, like I said, Japan has really long land, and then there's a lot of islands, and then a lot of people is living inside, and not many Christians, but at least 9,500 churches are there. That's the state of Japan. And that's why I think unreached area concept can be applied to Japan, but not only Japan, but also other unreached people groups could be using this unreached area concept. Why? Because recently I calculated the unreached people group data and then found out that 33 groups consists 900 million people population. This means there's a lot, really huge unreached people group, small number of groups, but a lot of population is occupied by those people. And they are spread into, I'm guessing, the vast land, not a narrow place, because they are not living in a village, but they are spread into many cities. So this is the basis I suggest. Unreached area concept can be applied into these bigger groups, which is smaller in number, but huge in population. And you might wonder where this chart came from. And this is coming from another language called Python. I said I was using Kotlin for church and station project, but for this lecture, I started to practice Python language. Why? Because if I talk about data processing, data science, and data related technology, I have to know what Python is because it's most popular language. So this is how I use Python in a real data science beginning project. And so it was easy for me, and then it could be easier for you too if you have time and passion. So if you want to start any Python project and then start data science, this is the steps I can introduce. So first, there's 2 books for beginners. And then our third step is to download data and work on it. And there's a step-by-step instructions in the books, so you can, click the link after this lecture and then start to read. These 2 books are free book, online free book. But, for some of you, it will be difficult because of, time or, just familiarity, just you're not familiar with the technology. So in that case, if you still want to incorporate the power of technology into your mission study, there could be some other options. So the first option, this is just my idea about hiring secure programmer, or start to find somebody who can cooperate with you as a volunteer in a Christian circle, or raising tech-savvy missiologists from students. And the reason why I put these 3 options is there are many ways. There should be more ways. Even though you are not familiar with technology, you can still, cooperate with other people to enhance your study, mission study. But you might wonder why I'm doing mission study with the, great help of technology, and I'm not, feeling difficult in technology. That's because of my school. My school was founded for this purpose. Everybody who graduates Olivet Institute of Technology is mission-focused people, professionals, leaders, and schools, and they learn technology for missions. That's the purpose of this school. That's why I can do this. And then this is thanks to the people who created this school, founded this school. I want to name Dr. David J. Jang, and also his mentor. Actually, his mentor was Ralph D. Winter. So both of them try to make the school, which is focusing on mission and train people to raise the tech professionals. And then you might wonder why this Missioinformatics name came from, where it came from. It's because, just because there's a famous word in academic field, science field, it's called bioinformatics. And it's really popular. That's why I use the word, reword the prefix from bio to missio. Let me finish in 2 minutes. Bio something is really famous. Let me give you some facts. The top 10 papers were mostly bio papers, bioscience, biotechnology, and bioinformatics. And when we do some work, I think corresponding academic field should be there for the advancement of the field. So that's why I call it Missioinformatics as a name of academic field, new field. And this is the information for you. These are the links for the introductions for other informatics field. So there's many something informatics, not only bioinformatics, but there's geoinformatics, which is operating IT for geography, and urban informatics for urban sociology, and behavior informatics is cooperating behavior science and IT. And I think there's many people who is studying missiology or mission using the anthropology methods. And then there is also academic field called digital anthropology. So this link might be helpful for you. Okay, so this will be the end of my lecture. Thank you for listening.
Great. Well, thank you, Joel, and I really appreciated that. For everybody who's here part of the group, one of the things I note is if you want to ask a question of Joel, go down to the bottom and click the reactions button, and then there will be a panel and it says raise hand, and if you click on that, then I can recognize you and you can ask a question. But Joel, let me start off and ask a couple of questions in terms about your research that you showed. You showed the research in terms of distance from train stations in Japan. And
right.
Yeah, and so just a quick question in terms of maps that you had. You showed one map of Japan with a blue streak right through the center. What did that blue streak represent?
Blue streak, I mean a blue line?
Yeah.
Oh, that's the railway.
Okay, that's the railway line. And then it kind of, so that was to show how many churches are close or not close then?
Blue one is railway to remember where is the stations. Actually, there's only stations with graphs if the station have more than 1,000 passengers.
Oh, okay.
And then if the station have less than 1,000 passengers, I didn't put graph. Okay. But station names are displayed. And then
I saw that, yeah.
Station names are displayed on the blue line. That's why there's a blue line.
Okay, now the next question about the graphs. In the one that you showed of the map, there were some with like gold bars coming up and other with blue bars coming up. What did those bars represent?
Right, so gold bars are the stations which is already reached by the church.
Okay, so it's pretty close, the church to the station.
Close to church, right. And then blue bars, there's no church around.
No church around, or
right.
beyond 3,000 meters, or beyond 500 meters, beyond 1,000 meters. How did you determine no church around?
Actually, there's a control bar, to change the distance, and then according to the specified distance, the graph's color changes actually.
Oh, okay. So it's brighter or bluer depending on how.
Right. Blue or orange.
Yeah. Okay.
Yeah.
Finally, just a question in terms of who was. No, you don't have to tell me who because that's kind of private information. But what did the people that you worked with to get this information use it? Has this resulted in church planting by mission groups in light of your data, or is that just beginning to be discussed?
It's beginning state.
Yeah, because it's pretty new research.
Yeah.
Are you going to continue this research to see how this shifts? Because let's say people follow up on your database and go, oh, okay, we're going to plant a church here and church here and church here. Will you follow that in terms of your data collection and in a database?
As possible, I want to follow, but my capability and my employer too.
Okay, last question, and then we've got a couple hands up. The final thing is, do each of you in Japan keep your own database, or do you have a joint database where information is going to, and then people can go to it and then take it out and manipulate the data in light of the questions that they're asking? or does each group have their own database so that they look at that data? Do you have a joint kind of silo for information in Japan in terms of the church?
Kind of, yes, but they are struggling with the non-Japanese churches.
Okay.
There's many, Chinese-speaking churches or Korean churches that's not contacting with Japanese churches. That's why it's getting really difficult to gather all the churches which speaks any language in Japan. And the collecting of church data is kind of really challenging. But
I can see that. You might need a flag that says Korean speaking, Chinese speaking, Japanese speaking, and then you have an extra data point. So then you can look at it and go, oh, well, we've got close, but the close is Korean and no one can speak that language. So distance doesn't matter because people go there, they don't know the language.
Right.
So
that's right.
So just a physical church. So a little bit more data then gives you more precision in terms of which one. Well, good. Thank you very much. And I will turn to Tim. Tim, who's going to ask a question then? Is that Damon?
Yeah, I have a question. Well, I think your methodology is useful, but I've been very interested in the result. But you didn't spend that much time talking about the interpretation of your result. So I'm interested, say, the distribution of the churches in terms of the distance from the station. You understand my questions?
Can you rephrase that?
Yeah, the distribution of the churches as a function of the distance from the station. For example, say between 0 and 100 meters or 200 meters, 2% of the churches are located in that radius.
And then?
Between 200 meters and 600 meters, another 5% of the churches are located in that ring. And from 600 meters to 1,000 meters, another 5% located in the ring, so that you get a sense of where the churches are located in terms of the distance from the station.
Right. And then?
And see where the churches mostly are gathered in terms of distance from the station.
Populated areas. If there's more population nearby?
No, it's not about population, it's about the number of churches as a function of the distance from the station. See, that would tell us where the churches are located in terms of distance from the station. If the churches are located very, very far, say most of the churches are located more than 2 kilometers from the station. Okay, we have a problem. We have a problem in the strategy, because if the church is so far from the station, of course, not many people are willing to come unless they drive.
Right. So when I calculate the distance, I limited the maximum distance to the 5 kilometers.
Yeah.
In the map, only the maximum on the map is 3 kilometers.
Yeah, but what I want to see is the distribution of churches in terms of the distance from the station. That would tell us something, a meaningful understanding of the physical distribution of the churches in relation to the station. So that's one thing. That's one way of looking at it. The other way of looking at it, you look at the largest churches. You look at the largest churches and find out where are they located in relation to the stations. So that might give you some idea. If the churches are located, say, within 1,000 meters from the station, well, the size of the church will be over 100 or 200, something. If there's a correlation, the further you get from the station, the smaller. So that gives you some idea that distance does matter.
Yeah, that's right. And then one thing I want to emphasize was actually my focus was not the churches. My focus was the places and where there is no churches. So I didn't even think about the names of or churches, names of the churches or size of the churches or any other information about churches, because the somewhere already planted.
Yeah. No. Okay.
That's why I didn't spend much analysis on the existing churches.
I get your point, but what comes out of this conversation is that the data that you have collected, they're more valuable than your original intention, because they can be used in more ways than you have thought about, and they actually, depending on the way that you interpret the data, you can actually get more valuable information out of them. Which
I think so. I think so too. Yeah, I agree with that. And then for your information, the data is public. Anybody can access. It's in the link.
Yeah, perhaps we can interact afterwards. I'll get your email address from Tom.
Yeah.
I'll ask for more.
The data is free for everybody. It's open data.
Yeah. Okay.
Okay, well, let's go with Regina. Regina, go ahead and ask your question.
He's not asking the same question.
Okay. Thank you, Joel, for this presentation today. That was an enormous project, massive project, and I can see a lot of implications for future research based on that around, like you mentioned, around other unreached people groups. One question I had, though, in the very beginning, when you were just collecting your data and you spent that year researching where the churches are and where they are not, you interviewed some people to get an idea of what distance they would be willing to travel from the station. Who were the people you interviewed, and how many did you interview?
Oh, actually, the interviewer was not me, but government of Japan. They did a really huge survey some years ago, and then I just used their result of the survey.
Okay. And that was in relation to going to church, the government's survey?
Oh, it's a general public, and then it's a daily life or commuting or going to buy some foods or any type of work.
Okay. And that was just a big data that you drew from?
Yeah, I think so.
All right, great. Thank you very much.
You
welcome.
should add a point, though, that Christians are willing to go the extra mile, so.
Yeah.
Just kidding.
Yeah, I wondered if it could be nuanced to where you're asking them, are they willing to go how far for church, particularly, not just social community?
Yeah, I would agree with that too, Regina. I think some qualitative work going alongside and some questioning to find out, the depth and roundness of the data and what it tells you. So yeah. Let's go with Phil. Go ahead, Phil. You're on mute, Phil, so unmute. There you go.
Sorry about that. Thanks, Joel, for that. And I think that previous conversation around, and it's one of the things that I've been struck by, is we look at mission data. And I'm actually involved in mission leadership and looking at what is the data we need to make good decisions. And I'm struck by the fact that I don't think in many mission circles we have an understanding of what data is available or what data we should look for, and then how we should make, or how we can make use of that data. I think in many of our organizations, we have probably lots of data in relatively inaccessible formats hanging around, some of which is of limited value. And there is other data that's either publicly available or that we don't gather that would be of enormous value if we were able to intentionally capture that data and make good use of it. And so I think there's a whole piece here around, as you talk Missioinformatics, about just helping us within a missions community understand really the data that we're leaving sit that we should actually be making use of, whether it's, you know, the sort of thing that you have done of understanding how many churches are or are not in proximity to a train station, but even within our own organizational structures and organizations of what data should we be trying to capture to help us make wise decisions, and then understanding that there are, you know, there are gifted Christian data scientists who could help us make sense of what we might think is really tough. Because I'm sitting here going, I don't have time to learn Python and try and, but there are people who are like, they're gifted in that. That's what, you know, can do. And suddenly to bring that together, to be able to really powerfully visualize some of the realities of our different contexts, the worlds that we function in. And so I share that as, it's a challenge to myself. And it's one of the reasons I'm here, just wrestling with this piece of how do we at an organizational level, for senior executives level leaders, for our boards, are, you know, are we giving our boards and our executive level leaders access to this sort of information? And I can say for our organization, we're looking at it, but how to do it, and how do you invest in something that people don't know the power of?
My suggestion will be, first, that, like I said, that data is available in big company or government. That's the two places where you can get that, you know, such kind of data. And for big company, I don't recommend them, but for government, there is open data department, the department or agency, which is focusing on working to open the data to the public for the use of the, you know, companies and the other organizations. So there are, if you search on Google in your city or in your country, many experts for open data for usually government, and look for those people. And then if that person is Christian, that's better. But if they're not, if the person is not Christian, even fine actually, because those people are available for cooperation with the non-government entity to the use of the data, and then make something valuable from that data, which government is providing to the public. So that would be my suggestion.
If I could come in there, Joel, and partly connect with you too, Phil. What Joel's saying, I think, is something we need to think about missionally. And if you go back in the series, we had a guy who's actually does Alzheimer's research here at Oxford. And what they've created is a massive data bank, and also people to work with different people coming in who, like you, Phil, are asking questions about. What I'd really like to find out is this. And it seems like to me there's a couple of things that happen then. First, there's a conversation where you can come alongside and assist in finding that information, if it is publicly available, because that's a skill in itself. You know, Joel, I mean, it's one thing to say, oh yeah, you know, but you know, one of my questions I was about to ask, but I'm not going to ask it, is how did you know to go to the Japanese study on how people are farther willing to walk to a market? All right, so part of navigating that is a skill set that's learned, but not every mission agency working has that kind of skill set. But if you had a middle group that was assisting research and helping to find that data, or even directing people how to go and how to get the information they need. I think the second thing is it would start to appear even in that, and I think this follows up with Regina's question, is that then based on that, we have this, how could we find out a little bit more? All right, and then we can actually design a study. So let's say, oh, well, people go to big churches near train stations, but not small churches. All right. So then we can do a study, or maybe we need to have a different style of church or something like that. I mean, it could go in a million different ways. But I think what I'm hearing and what I'm thinking is is if there was a hub where different groups and mission agencies and churches could come together to find out good information like what you've done, Joel, and then take it, ask the questions of it, manipulate it, so it comes up with the kind of resource that would help executives like Phil to go, okay, let's try this. Given what we know, given this data, which is really helpful, now let's build a strategy around that and then continue to follow up. But that's just my thought on that. That's kind of where I sense we got a long ways to go, but I think that's what would be good for an OCMS or something like that to do, to help people to process and gain information that's helpful, not just study any old information, but information of the questions that are being asked by different agencies in terms of getting in. Regina, go ahead.
So actually, mine is more of a comment to this discussion. And what I found in my own research is that there are these big data databases, these depositories. Hospitals have 20, 30 years of data collected, very statistical demographic data. But the problem is in social science, and particularly in missiology, we don't have depositories of social science data that we can readily go to and use that. So we're always in the process of collecting the data ourselves, setting out surveys, and then you meet with the difficulties of whether or not people will participate in that, and whether it is a random sampling versus a convenient sampling, which again, the generalizability of the data depends on those different types of sample sets. So I think the vision to start a depository for missiological work is a critical need, but it's going to be very messy and very complicated to gather that, because we have to be willing to share the data that we get with others who are also then having to collect that data in their organization, their para groups or whatever. And so I think we have to start somewhere though, right? If we continue to see the need, but we don't step into it and try to figure out a solution, then we just perpetuate the problem. I would love to have had a database where I could have gone to and asked church planters or church leaders to help me in my research. And as it turned out, it almost becomes an organizational study, because it's too difficult to collect unless you do it at a denominational level. So I think these lecture series have highlighted the need for that, the need for us to begin looking at these depositories of data that will help us in the area of missiology particularly. And I think it's to be commended that OCMS is looking into that and beginning to dialogue and see how that could come about. But I think it's going to be just a tremendous amount of organizations around the world in global missiology collecting and working together to share that data.
Yeah, I think that's right, Regina, and a really good point. The other thing that, the other aspect of that, my son's involved with this, he does big data studies on behavioral economics, but he's got the federal treasury behind him. So he just goes in the closet and what they do is actually, they look at what they want to find out, then they work at designing studies that would do that. Well, they know how to do that, but they don't do it itself. Then they put it out on the market for companies to bid on doing the research. So they set it up and then they all put in bids, and these companies all surround Washington, DC. And when they see a bid go up, they look at what the research is, and then they say, I'll do it for this much or whatever. But with mission data it might be a little different, in the sense we don't have anything to offer but prayer and blessing. But if we had some people that were ready to take on projects of the in-between parts, that would be great. So we could look at, this is what we want to do. And this is what, so, and somebody goes, well, we'll do that. We'll take that forward, and we'll go do that. So yeah, I'm gonna phone call, but I'm not gonna answer it. So, any other questions? Well, Joel, I just want to thank you so much for a great lecture. Yeah, I'm going to send email around so people can get in contact with you. And also, Joel, as we go forward, you being an expert in this area, it will be good to keep our connection up. And Phil, thank you for coming in. It's nice to get someone in from who's trying to work with this stuff and see its effectiveness. And we need to hear, as well as we develop this and go forward, from those who would actually be using the data and how to set that up. Because a lot of times when you get your head stuck in a library too long, you forget about the right questions to ask. So anyway, blessings upon you all and have a great day. And Joel, have a good night's sleep because it's late at night in Japan.
Good night. Good night. Thank you.
All right, take care. Bye-bye.